So I see that Ram was not able to see the screen. Can others confirm that whether you're able to see the lab topology? Okay, perfect. Ram, it looks like an issue on your side. Please fix that. And there is one more question. Is the course friendly for beginners? So, Ramu, we expect you to have basic knowledge or a CCNA level knowledge because we won't be explaining DHCP or NAT or anything again in this course. So, if you have understanding on the CCNA level, you'll be able to grasp this course. Okay, so before starting the session, let me give a quick intro about myself. My name is Vinod, and I have the chance to work with Fortinet, Fortigate products for the last 4 years. So day in, day out, I work on Fortigate firewalls, both hardware and VM, as well as FortiManager or FortiAnalyzer, Authenticator, other products. So we will use this opportunity, and I really want to appreciate all you for taking this effort and time to join this session, that too on a Saturday morning. So in this session, in this upcoming 6 days, we will not learn everything about Fortigate, but we will learn the basics, how to get started with Fortigate, how to get familiar with the GUI, certain basic features, what Fortigate can do. Those things we will discuss in these 6 days, but there are certain topics which we cannot discuss in a very short time. For example, ADVPN or SDVPN. These features they have so many options, and the use cases varies a lot. And based on the use case, the deployment also changes. So those kind of advanced topics we will discuss later in our course because the time is not sufficient for us to discuss in 6 days. Now, before starting or explaining what is Fortigate, I wanted to take the opportunity to discuss the general history. What is firewall? How we got into this firewall technology? So, starting in 1990s, we have this very early stage of firewall, which is called as packet filters. So packet filters are, this is not a dedicated firewall device, but it's more like a router or switch based device, and they have an option to use ACLs or extended ACLs. And based on this ACL configuration, you can filter certain IP, certain port numbers. So the primitive firewalls were limited to uh, TCP layer 3 or layer 4 based filtering. And another thing to note here is when we say layer 3 and layer 4, these are like stateless firewalls. So when we say stateless, these firewalls cannot expect a session on the reverse direction. So if let's say if in these packet-based firewalls, let me note, in these packet-based firewalls, if I write a rule which says traffic can go from in direction to out direction, it can only allow packets on this direction. It cannot allow the packet in the other way. So for the return traffic to come, you have to write another rule which says out to in. So this is the early stage of firewall where it can only take decisions based on layer 3 and layer 4 information. But later, a stateful firewall came in. So stateful firewall, when we say it solves the problem of stateless, where it can maintain sessions. So maintain states. So when we say states, now this firewall, we don't have to create two different rules in the stateful firewall. There'll be one rule which says traffic can go from in to out, and the same rule can be used to allow traffic coming from out to in direction. Now, how this out to in direction is created, it's based on the 5 tuples. So when we say 5 tuples, so basically it'll be source IP, destination IP, then protocol, source port, destination port. Now, these 5 tuples are only generally applicable for Fortigate, but different vendors use different tuples. Like Palo Alto uses source interface as one of the tuple. So now, based on these 5 information, a session can be created on the firewall and it can be maintained. Now, if I am creating a session based on the source IP and destination IP, along with protocol and port number from the in to out direction for the return traffic, which we are expecting on the firewall, these parameters will not change, but only the direction will switch. So based on this, firewall can maintain a session, and that is what the stateful firewall is. Now, the stateful firewall is good for lower layer checks, but it's not sufficient, or it won't be able, it's not capable of performing layer 7 inspection or application layer inspection. Now, to solve this problem where we cannot inspect the layer 7, the engineers came up with application firewall. Now this application firewall at this point in early 1990 period, it's like a standalone device. It's not combined as a firewall which we see today. So this application firewalls are standalone devices, mostly like UTM devices. So these devices have the capability to inspect HTTP and SMTP traffic. So they can inspect specific applications, and they can also enforce IPS, intrusion prevention, or web filtering functionalities. But again, these are not firewalls which we see today. These are early stage of the firewalls which we see nowadays, like a standalone device which is capable only of performing layer 7 inspection. So the strong point for these application firewall is their capability to decrypt traffic. So if the session is encrypted, like if it's a HTTPS traffic, these application firewalls have the capability and power to decrypt the traffic and then inspect the traffic for any malware or intrusion prevention things. And also they can perform web filtering, where you can they can provide you access to facebook.com, but they can block Facebook chat. So such capabilities were bought in because these firewalls are capable of doing decryption. Now, at this point in time, network engineers, they deploy a stateful firewall in the perimeter and an application firewall in their LAN segment, where all the traffic will be sent to application firewall, inspected, and then it will be sent to stateful firewall to be forwarded out. But this has its own over complexity and challenges in terms of maintaining and troubleshooting this. Then came the UTM firewalls, or UTM, or next generation firewalls. Now, when we say UTM, it stands for Unified Threat Management, where it combines both the capabilities of stateful firewall and application firewall. So UTM firewalls can maintain a session table, and at the same time, they can inspect application layer traffic or layer 7 traffic. Now, when we say it can inspect layer 7 traffic, now they are capable of handling IPS, web filtering, anti-spam, antivirus, and all these capabilities are now binded in a single form factor. So there is no challenge in terms of configuration, deployment. There is no over complexity, which we saw in case of application firewall. So UTM firewalls, since they are a single package, a single form factor, they are capable of all the advantages which we have in both stateful and application firewall. Now, since this UTM firewalls, since they are performing this decryption and task where they have to inspect for IPS and layer 7, now they require a lot of processing power. So this processing power is costly, and it's not easy to adapt for everyone. So this early stage of UTM firewalls were adopted by small to medium enterprise customers, where their bandwidth requirement is very low. Uh, in a way, like it can handle traffic till 1 Gbps, but if if it's a deployment, let's say like an ISP deployment where they expect a lot of traffic, maybe in 100 GBs or terabytes, early stage of UTM firewalls are not capable because their CPU is not powerful enough. Now, to solve this problem, then came the enterprise firewalls, which we use nowadays. So the that is what we call as next generation firewalls nowadays. Nowadays, enterprise firewalls are also referred as next generation firewalls. And this particular NGFW term is coined by an analyst firm called Gartner. Um, I'm sure some of you might be aware about what this term Gartner. Gartner is an institution which rates and ranks the firewall for various capabilities. So you will see firewalls being advertising themselves as number one, number two in the market, and all those ranks are mostly based on the Gartner result. So this Gartner came up with the idea where UTM concept in an all-in-one solution. So now this with this enterprising firewall, that is NGFW, we have the tremendous control over the traffic. Now traffic can be inspected at a granular level where what the enterprise security is seeking. So when we say enterprise customers, it can be anyone like TCS, Wipro. So they need a lot of controls on their traffic to keep their network and resources safe. So this level of control can be provided by NGFW, and this NGFW they are very powerful. Now this nowadays these NGFW will come from it starts from a normally like 4-core CPU all the way till 64-core CPU. So nowadays these devices are very powerful, and they can decrypt a lot of traffic. They can maintain like millions of sessions at the same time. And they are very capable. Even their performance is very capable nowadays. We have firewalls in the range of which can handle a throughput of TBBS, that is terabytes. So such powerful devices we have nowadays in the market. Now, this is just a brief history on what firewall and the evolution of firewall. Now, but today's network is not something which we see in the early 1990s. Today's network is very complex. When I say complex, the deployment model varies a lot. Nowadays, most of us have adopted this work from home option. Most of our servers are not hosted locally. Data centers are migrated to cloud. We have remote offices everywhere. So the setup has turned very complex nowadays. So let me bring up. So this is what this is a broad picture which refers to a setup which we have nowadays. If you take any enterprise networks, any enterprise customers or their network deployment, you will see all these 5 layers of firewalls nowadays. It's not like the simple hub and spoke or Cisco 3-layer architecture nowadays. Nowadays, the setup has expanded geographically and physically. So, and the complexity has also been increased in similar ways. So each layers which we define here as enterprise firewalls or cloud, next generation data center or segmentation firewalls, they all have different functionalities, and they are designed for specific courses. So if you are in a position and if you are a network designer and if you have to choose a firewall for these deployments, you have to keep in mind what purpose you are going to serve and in which layer you are going to place the firewall. Based on that, the firewall which you choose will vary. We will discuss these different firewalls and what features we will focus on different layers. So there's a question from Murugan. Shall we get the course recording? So Murugan, the course is currently being recorded, and we will share it with you later. So Gunal has a question how to create an IPsec site-to-site VPN. Gunal, this is an advanced topic which we will discuss in our later days of training. Okay, so let's start from the distributed enterprise firewall layer. So distributed enterprise firewalls are designed to protect large and geographically dispersed organizations. So let's say we have KFC, Domino's, Royal Enfield, which are service centers or sales shops all across the country. So they don't need a big chunky firewall or a very capable or powerful firewalls, which has like 10 CPUs or 250 GB of RAM. We don't need such power at this level. Most of these remote offices will hardly have two PCs, maybe two POC machines. So their power can be limited. And these most of the time, these distributed for offices, they are in remote locations where uh, maybe everyone working there won't have a good idea on the network or how to manage a firewall. So these firewalls will have a capability where you can manage those firewalls from the cloud or from your data center, which we will discuss in later part. And these are satellite offices, which is very essential because more these satellite offices will have a connection to your DC or your application server which you're hosting. So protecting your network at the from the external threats is a strong line of defense. So we cannot leave any nodes in the network to be compromised. One moment. Yeah, as I was saying, so these distributed firewalls, they are smaller devices installed in branch and mostly in remote sites, and they don't follow an enterprise network design. When we say enterprise network design, you won't find a three-layer hierarchy model in your remote offices. If you, for example, if you visit any KFC, for example, they will have one firewall and they will have an access point, wireless access point connected to that firewall, which can act as a switch if needed. And through this wireless access point, maybe a couple of laptops will be connected to the network, or you will get four ports, 4 to 8 ports in the firewall, which you can use to connect your laptops. And your POC machines, they will connect over Wi-Fi with the access point. So this is what the setup in a remote office will look like. You won't find a distribution layer, you won't find the access layer or a core layer in these kind of offices. And but still, customers don't, or the enterprise engineers, they don't want this distributed firewalls to be a stateful firewall or a stateless firewall or a very primitive packet-based filtering firewalls. They still want these firewalls to perform IPS web filtering and antivirus inspection. So this is where the next generation firewall comes in. So next generation firewalls in small form factor, which will have typically 2 GB of memory and 2 to 4 CPU cores. So these kind of firewalls will be deployed in a distributed enterprise level, and they can have a maximum throughput of 1 Gbps because that is what's expected out of these locations. So in Fortigate, you have several options for this, starting from 30D, 30E, then going to 40F, 50E, and all the way till G series. Nowadays, we also have G series firewalls, so these can be deployed for small offices. And most of these firewalls, interestingly, they are countertop firewalls, so they will look like a very small home-based routers, which we use nowadays, and can be placed on a counter. Now, next comes the cloud firewall. So when we say cloud firewall, this is important because nowadays maintaining a data center locally, it's very costly. It's not easy to maintain the power redundancy, and also complete service up with the local DC. So most of the services or applications have already been migrated to cloud, but still we wanted to protect all the server instances which we have in cloud. That is where the cloud firewalls comes in. So the same FortiGate, same FortiOS based inspection can be deployed in AWS or GCP. So, but the only catch here is now the power or the performance is not dependent on the actual physical firewalls. The performance is dependent on the servers in which the VMs are installed. I'm sorry, I'm getting distracted by so many chats, but if I start answering those questions now, I won't be able to go through the topic. So I will come back to those questions later. So the reason why these cloud firewalls are important is again, if these cloud firewalls will have mostly have a VPN, an IPsec or dial-up based VPNs connecting back to your main DC or your home office or branch of main location. So if this level is compromised, your end-to-end network will be compromised. So it is very important to protect all your servers in cloud by using any cloud firewall. So this is where it's important. Now next comes the next generation firewall. So this is the traditional firewall which we all think. So when we think of a firewall, we think of it as a perimeter defense. So this is where the NGFW comes in. So this layer sits at the perimeter where your WAN links will get connected. This is your breakout point. And so for this, because of this reason, we need these firewalls to be capable of intrusion prevention. So they should be able to scan the traffic for any malicious patterns or any malwares. Then they should be aware of the application, because nowadays we have this great functionality SD-WAN. So based on the and it works really well by detecting the application. So let's say if you're hosting a Zoom server or your own audio conferencing system, you don't want your audio traffic to be you want your audio traffic to be prioritized. So you want, or if let's say if you're deploying a SAP application, you don't want latency in your SAP. So in such scenarios, you want the firewall to give certain priority or weightage to mission critical applications. So that is where the application awareness comes in. So firewall is capable of detecting what kind of application traffic that is being traversing the network, and it can give priority or it can process it accordingly. And also you want this next generation firewalls to be capable of deep packet inspection, so that they can decrypt your SSL or SSL session, and then they can take action accordingly. So NGFW, they provides heightened level of security and visibility, and it's very suitable for today's advanced threats. So usually these firewalls are deployed for application visibility and intrusion prevention and malware detection, and also for VPN purposes. Because most of these distributed enterprise firewalls or your cloud firewalls, they will have a VPN connection back to your home office. So that is where this enterprise firewall sits in. Now, in terms of capability, these firewalls are expected to have processing power, or they should be able to handle 1 GB to 40 Gbps traffic. That is what's expected. But if you're looking for a higher performance or a higher bandwidth capability, models are available in the market nowadays. So next comes the data center firewalls. So data center firewalls, they are very important for today's organization's digital asset, because this is where your server farms will be located. All your critical applications will be running out of your DC. So it's not like, since we have a perimeter firewall, we cannot ignore our data center firewall, because threat can come from anywhere. So we still want a firewall at our DC level, but a challenge or the catch is we want these DC firewalls to be high performance, because we don't want any latency in our application. So the minimum requirement is these firewalls should be capable of handling traffic from 10 Gbps to 1 Tbps. That is what's expected out of these DC firewalls. But the security functionality are kept to a minimum. So these firewalls will perform basic firewalling like access controls. They will provide application level controls, and they will also do IPS. But since we have a firewall at the perimeter which does the decryption, we don't want the DC firewalls again to perform the decryption, because decryption is CPU intensive. So, but the main focus at this DC level is about throughput performance, not about decryption. So usually if you're deploying a firewall at DC level, you won't configure policies in proxy, or you won't configure these firewalls to perform decryption into the traffic. Now, then came the internal segmentation firewall. So internal segmentation firewall, this typically comes in your LAN side. So because nowadays it's not that any security threat will come from the outside the organization. Uh, the threat traffic can be can originate from inside the network as well. Give me a minute, please. Okay, I'm back. So this internal segmentation firewall, this provides us the option to split our network into multiple security segments. So that is easy. And one of the very important steps in security is segmenting or limiting the breach or controlling the threat exposure level. So if we segment our network effectively, and if any particular if one of the segment is compromised, it won't compromise other layers. So that is why this internal segmentation is very important. And these firewalls typically are capable of doing basic firewalling, like policy or access controls. And they also perform application control, web filtering, and IPS. Now, web filtering is a very important feature here, because you don't want your traffic to traverse through internal and then come to your perimeter, or to be denied, saying that you're not allowed to access a particular URL category. You want those category based filtering to be done at your internal segments level. So to perform this web filter based actions effectively, these firewalls should be capable of performing decryption. So these firewalls are capable of doing decryption, and the target throughput which we normally aim for this internal segment is from 1 to 100 Gbps. So mostly these internal segment firewalls will be small, medium-sized firewalls, and your next generation of perimeter firewalls will be like large model firewalls. So when we deploy, these are the various firewall options, various scenarios in which we deploy your firewall. But now these are the broader terms. Till now, we haven't focused anything specific to Fortigate. So let's going forward, let's discuss something specific to Fortigate. So in Fortigate, there are three modes of deployment. So the first one is the NAT mode or the route mode, which is also the default mode of the firewall. And then we have virtual wire mode, and then we have transparent mode. So let's discuss what's the difference between these three modes and where we will use these deployments. So first, let's discuss about the NAT mode or route mode. So when the firewall is deployed in a NAT mode, it's a typical L3 device, or it's kind of an L3 router, which is capable and responsible for routing traffic between different network segments. So in this example, we have a segment which is like so we have 192.168.0.0/24 here and 198.51.100.0/24 here. So two different segments. So this firewall in between, which is working in NAT mode or route mode, is capable of performing basic routing between these two segments. So this is what's expected out of this L3 mode or NAT mode. But along with that, it also have the additional capabilities of firewall. Now, these NAT mode devices are usually deployed in perimeter and where SD-WAN is required, but it's not mandatory. So mainly deployed in perimeter where the FortiGate can run in NAT mode. So when we say NAT mode, now this device, let's say we have our internal LAN segment, which uses the firewall to connect to our ISP cloud. We want this device to perform natting. Because we can't expose our private network, and I believe everyone understands like the challenges which we have if we don't NAT traffic. So these devices will be capable of performing a NAT, and this NAT mode will function only if the interface has an IP address. Now that IP address can be static or dynamic. It can be manually assigned or it can be learned from DHCP. And it can also, these NAT mode devices can also make decisions based on MAC addresses. So you can create MAC address based policy on your firewall, and that MAC address policies can be used in your NAT mode. Now, this is the simplest form of firewall, which I'm sure most of you are aware of, and we will discuss more about this NAT mode or route mode in our upcoming sessions. Now, the second method of deployment, let me move this. So the second method of deployment is what we call as virtual pair or virtual wire. So in virtual wire mode, the firewall is usually deployed between two different segments. So the firewall itself is not capable of performing routing or NAT, and it is not required to make any changes to your existing network topology. So if let's say if you're deploying a firewall in virtual wire mode, uh, this device is kind of invisible to your network. So the router is not aware that a firewall is in between, because when you route a packet from this device, the destination MAC will not be the firewall's interface MAC. The destination MAC will be of your VLANs or your server's MAC address. So the router is not aware of the firewall in between, and similarly, your servers are not aware of a firewall in between. So because of this reason, Now you don't have to make any changes to your existing network. You can directly deploy your firewall in virtual wire mode without disrupting your existing network. Now, why we need such kind of deployment? So this kind of deployment is needed where we will perform a study in a network, or we will see what kind of threats passing to the network, or if you want to compare your performance or capabilities of two different firewall vendors in your network. This is where you will deploy it. You will deploy them in virtual wire mode with a similar configuration, and you will see which firewall detects most of the threats or which firewall performs better. So the requirement is in this virtual wire mode, you will be pairing these two interfaces. So in the configuration itself is similar, where you are choose to pair two interface. So whatever traffic comes on one interface will be passed on to the other interface. There is no route lookup. There is no NATing involved. Whatever traffic comes in, it will directly send to the other interface based on the pair configuration. Now, this with this explanation, now you might think this is a bridge, but this device is acting like a bridge, but this is not really a bridge, and it can do even though it is behaving like a bridge, it can still perform firewall policies and it can control the traffic flow. So since let's say if we are deployed the firewall in virtual wire mode, and if it detects a threat, if there's a malware in the packet, firewall can still block that connection. Or let's say if you're from the internet trying to access your applications in VLAN 1 or VLAN 2, you can still write a security policy in the firewall to block this connection, even though the device is not actively participating in routing or NATing. You can still control your traffic using policies. Now, there can be situations where you want this device to perform NATing, so basically source NATing. So now this can be configured. It's not that you cannot configure NAT in your virtual wire mode. If we are using NATing in virtual wire mode, we will typically use it by configuring an IP pool and binding the pool to the policy. That is how we will do. It's a bit different from your normal NAT configuration in the firewall, but we will discuss those configurations in later discussions. And the last mode of deployment which we have is transparent mode. Now, transparent mode, it's very similar to virtual wire mode, but this kind of acts like a bridge. So whatever traffic we receive on one interface pair, it's sent to all the other interfaces in the same pair or same group. So it kind of acts like a bridge, and it is not capable of performing any NAT. It has no capability of doing any NAT. Its only purpose is to inspect traffic and to give us the power of monitoring. But in terms of virtual wire, you can have some level of control, but in transparent mode, you cannot have any control of the traffic. It's only for monitoring purpose. So we should be very careful when deploying this transparent mode between two different switches, because since the device itself is acting as a bridge, if we are not careful in segmenting the network, we will end up creating loops in the network. So we should be very careful when deploying the firewalls in transparent mode. Now this is for the basic deployment modes and what firewall is. Now let's take a look at the firewall GUI. Let's start some lab and let's see how things goes. So for students, so when you access your lab, let me explain it once again. So you have to access your lab from labs.networkgeek.in, and you have to log in with your mobile number along with the country code and the domain at the rate of ng, and the passcode is something which you will get from your ng application. So install the application and you will get the passcode from there and use this to log into the networks labs portal. Once you log into the labs portal, please navigate. You will be landing at the root directory. So from root, please choose your ng free labs, and here you will find a Fortigate bootcamp. So Fortigate bootcamp is this is something which we have designed for this 6-day course, and we will use this lab for upcoming 6 days. So once you open, you will have this lab topology. Now in this lab, all these three firewalls are licensed, so they have the basic licenses in it. But local firewall and remote firewall, they don't have any configuration. But perimeter firewall, on the other hand, it has some basic configuration done. So in this, you have routing configured and security policy along with NAT capabilities configured. So all these firewalls are deployed in our DC, and using this network, you have access to internet. So if you want any of these lab machines to access internet, they can be reachable through this network. So let me repeat this once again, how to access the lab. So please navigate to labs.networkgeek.in. And again, for this lab access purpose, there'll be a PDF document shared with you on the WhatsApp group. So log in with your country code, mobile number, and the domain at the rate of ng, and the passcode, which is something you will get from your mobile application. Once you sign in, you will be landing at this page, root directory. From here, choose the ng free labs, then Fortigate bootcamp, and the lab. No, so we have the basic configuration done. So when you open a lab, you won't find any configuration in it. So what you have to do is head to the import config page. Again, log in with the same username and password, and then please select this import option. So this will import the configuration which we have already set for these labs. So import them for perimeter firewall, remote firewall, and local firewall. And the PCs, they don't have any configuration to import. We have to configure them manually. So when we perform this import option, basically you are getting the licenses for these VMs. Now let's start one of this machine. So let's start the remote firewall and this remote PC. Let me have a quick access to this remote PC, and let me change its mode to check if its interface is set to DHCP mode. Okay, so it's set to DHCP mode. Good. Okay. So now this is where the actual course starts from. So the initial config and setup. So how do we get the initial access to the firewall? So I'm discussing specific to this lab. I'm discussing this initial setup in general. Okay, so when you let's say you are an enterprise network engineer and you are getting a firewall shipped to your location, so you open the box, you have a physical firewall, or if you deploy any firewall in your VM, AWS or GCP. So the firewall will comes with the management IP address 192.168.1.99/24 configured by default. So the default IP will be 192.168.1.99/24. And where this IP will be configured is something that changes depending on the platform. So if it's a high-end series or a mid-range series, if the firewall name starts from 100 or 200, 400, 600, or if the name starts from 1000, 2000, 4000, 6000, or 7000, these are the mid-range and high-end models. So in these models, the management interface, the dedicated out-of-band management interface will have this IP address 192.168.1.99/24. But if it's an entry level model, if it's something like 30E or 60F, 81F or G series models, these are entry level models. These models will have the port 1 or the internal interface, which is configured with the IP address 192.168.1.99/24. So you will see this marking which says either it's a port 1 interface or internal interface in the front plate. So if you physically see the firewall, you will see the name, and those interfaces will be configured with this IP address. Now the default mode for this firewall is NAT mode, which we discussed. So it's a by default it comes as a typical L3 device, and which is capable similar to a router. And we have to configure additional capabilities, or we have to enable certain features, and some of them will be based on the licensing. So once we enable those features, it will start behaving as a firewall. Now, now we have the IP address. Now, what about the services? So these management interfaces, they will have the services like ping, HTTPS, and SSH enabled on this management interface. So these are the default services which you will see enabled on the management interface. There are other services which we can enable. And also these management interface and this port 1, these interfaces are configured as a DHCP server. So if you configure your PC as a DHCP client, and if you connect them via a wire back to back, you will get an IP address assigned from the firewall. So firewall will act as a DHCP server on these interfaces, and you will get an IP address. So you don't have to remember the IP address. You just can assign your PC in DHCP mode, connect it, and just try to reach the whatever gateway, whatever IP you receive. Just try to reach the gateway of it. You will get the GUI access of the firewall, because by default HTTPS is enabled on the management interface. Now here comes the default login. By default, the username is admin and the password is blank. There is no password set by default. But as a network engineers, we have to change the password. It is not advisable to leave the default username credentials on the device. Um, I have seen a lot of customers doing this unknowingly. They leave their firewall with default credentials, and they will expose their firewall on the WAN interface. Anyone from the internet can access their firewalls, so it is not good. Now, the firewall can be accessed via console, the direct console port, or through CLI. Now, there is another method, CLI from the GUI, which I will show in later part. We call it as Java console. So we have various methods to access the firewall. So let's connect to the firewall. So it's all booted up. And since we have imported the license, since we have imported the licenses on this firewall, we were forced to change the username password because uh, if you're logging into a firewall out of the box, it will force you to set a password. So for that reason, we have set a password on these lab devices. So the username will be admin, and the password will be test@123, and the T will be caps. You will find the passwords here. If you click on the cheat sheet, it will list you all the username and password. So currently it's set to admin password. So this is wrong. We will change this. So the passwords set on these devices are admin and test@123 T caps. Now, once we log into the CLI, so let's check what this firewall is. So let's run the command get system status. So this is a Fortigate VM64-bit firewall, and this is a KVM-based firewall running in FortiOS 7.4.4. The security level is set to 2. There are 3 levels: level 0, level 1, and level 2. So the level 2 is the safest boot option. So level 2 will allow you to upgrade or downgrade only if the FortiOS image is verified and signed by Fortinet. So this is it's always good to deploy images in security, deploy firewalls in security level 2. Recently, there was a vulnerability which allowed hackers to gain access to the firewall's root directory and change or write some changes to the OS level. And those compromised firewalls were running on level 0. So it's always good to run on level 2. And then you have the various updates, security updates like antivirus, external DBs, then your application control signatures. So all those signature updates which we will get from the FortiGuard, which is kind of like a server Fortinet deploys, and all firewalls can connect to it and get the updates. So this is the serial number of the device. The license status, it says warning, because the reason being this device haven't got the chance to connect to internet and verify its license, validate its license. That is the reason why if you see the dates are all wrong. These are not the correct dates because firewall was not able to connect with the FortiGuard and then get its updates. So that is the reason why we see different dates here and the license status as warning. Now the number of CPUs allowed is 2. We are currently using 2 CPUs. That is what we have. Okay, let me show it here. Lab is closed. Okay, one moment. So we have on this model we have deployed 1. On this model we have deployed 2 CPUs, I believe, because I won't be able to edit it now. So 2 CPUs out of 4 is allowed, and we are using this much RAM on this device. So since this is a VM firewall, there is no dedicated log disk. But if you use a hardware firewall, some of the firewalls have a dedicated log disk. Private encryption is disabled. This is a feature where you will encrypt your disk. And if this is important thing, the default operating mode. So this firewall is operating in a NAT mode, and the virtual domain, or we call it as VDOMs in our firewalls. We refer it as VDOM. So we will discuss about VDOM in later part. So by default, the VDOM will be root, and you can configure maximum 10 VDOMs. FIPS, this is high security mode. These things we will check later. And then HA mode is standalone because there is no HA enabled. Okay, now let's see what IP address we have assigned on this firewall. So the command will be diagnose IP address list. So basically, there is no IP address configured manually. These are the default IP addresses. So 127.0.0.1, this is an internal loopback interface available on the firewall, and we cannot access it. This internal loopback is available for the process for various applications running in the firewall. So let me show the applications. So currently these are the various applications that is running in this firewall. And for these applications to communicate among themselves, we have this IP address 127.0.0.1. Now 10.255.1.1, this is something assigned to the Forti link. This is where your switches will come in. So there'll be dedicated interface Forti link, which is used to connect with Forti switch or Forti AP. So for that purpose, we have this interface created by default. VSys HA and VSys HA is for HA management. If we are deploying two firewalls in HA mode, then for their internal communication, they will use this particular IP address. Now, these are the same IP address, but the port combination will change when it's actually being used. And another thing to note here is the index. So index is basically an ID. So if you see, these are two different IDs and these are in two different VDOMs. So this particular VDOM basis HA is hidden. So you won't be able to access it normally because this is only used for HA purposes. And we also have an FGFM functionality. So again, this is in a separate VDOM. This is not accessible for us. It's for the firewall's own management. Now we don't have an IP address, so we cannot access it from your normal GUI. So currently I'm connected to the console. So how do we access the console of this firewall? Just click on this. You will get a pop-up. I'm getting the pop-up in my second window. So let me drag it here. So just click on your firewall once it's started and you will get the console access to the firewall. Now let me check what is the configuration which I have in my port 1. So if you remember, as we discussed, port 1 on the VMs or lower level models will act as a DHCP server. So currently, if you see, this particular device is acting in DHCP mode. So if I connect any device on the port 1, I will get an IP address assigned from that range, from the 192.168.99.0 range. But unfortunately, these VM firewalls are not configured with this particular range 192.168.99.1. Only physical firewalls will be configured with this range. So we have to manually configure the IP address on these ports. So I'm not going to access this device on port 1. So let me exit from this and let me configure my port 2. So config, so edit port 2. So again, it doesn't have an IP address. So let me set an IP address. Or let me do one thing. Let me show the same things in GUI, so that will be very easy for you. So edit port 1, set IP. I'm configuring this IP address 192.168.1.3. Subnet mask. Can't change dynamic IP. So if you remember, this is set to DHCP mode. So let's change the mode to static. So now we can configure the IP address. So now I have the port 1 of this interface configured with 192.168.1.3, and it has the access ping, HTTPS, SSH, and HTTP allowed. So let's apply this configuration. So in Fortigate from CLI, if you hit end, the config will be applied. Now, if I verify the IP address on this, diagnose IP address list, you will see my port 1 configured with 192.168.1.3. Let me start this PC. I wanted to show DHCP capability on this port too. So let me access the GUI of this firewall using this administrator PC, and then I will demonstrate this. So again, to access the Linux machines, just click on it. You will have the VNC opened. I'm having it on the another window. So let me check the network. So it's set to DHCP. Oh, I should have left it on DHCP mode. Okay, let's make it manual. 168 dot, what was the network? 1.254. And gateway, let's leave it now. DNS, it's okay. Apply. So let's see if I can ping the gateway. 192.168, 1.3. That's what we configured. Network is unreachable. So IP address. Okay, disconnected. Oh, I have to disable and enable it once. Okay, got it. Okay, let's try now. Okay, so I'm able to reach the device. So keep this in mind in lab. If you're configuring the IP address on the adapters, you have to disable the adapter and enable it once. So now I can reach the firewall on 1.3 IP address. Let me access it from the GUI. So it will ask for the root password. The password is root for the Linux machines. So let's say HTTPS 192.168.1.3. That is the IP which we configured. So you will be getting this connection not private. So we are getting this error message because of the certificate, because the certificate which I am getting from the firewall is this Fortinet certificate, and it doesn't have a trusted root CA. So since I don't have a trusted root CA installed on this browser or this machine, I'll be getting this warning. So we can ignore this. So this will be the default login page, and the username will be admin, and the password will be test at the rate of 123 T caps. So T at the rate of 123. So it will ask you to migrate with config converter. We can ignore it. So this is the login page for our firewall. So the dashboard for our firewall. So you will see the same information which we verified in the CLI, the serial number, host name we can change, firmware version, the default mode is NAT, your system uptime and the system time along with the WAN IP address. Now, the reason why the WAN IP address is marked as unknown is because I have not configured the port 3 and port 4 and the perimeter firewall is turned off. So if I turn on the perimeter firewall and if I configure these ports, then I'll be able to access the internet. Once this firewall is given, remote firewall is given internet access, I can connect to the FortiGuard servers. That is a content server deployed by Fortinet. So once it connects to the FortiGuard server, it will be able to validate the license. It will be able to download all the security patches. That is the signature updates. So currently there is no firmware. If I check the FortiGuard feature here, it shows like it's not able to validate the license. Once we get the license validated, you will see the list of all these updates services being available for us. No, we in the upcoming sessions we will discuss all these options which is available for us. But now for today's topic, let's head to the initial configuration, that is interface configuration. So to access the internet, please head to the network tab on your left side and hit the interface. So this is where you will get the interface options. Now, if you focus here, there is an interface called FortiLink, and it is dedicated to FortiSwitch. So if you have a FortiSwitch model, then you will be able to connect your FortiSwitch on this interface, FortiLink interface, and you will be able to manage your switches directly from the firewall. So you will have those options here under wireless controller, Wi-Fi controllers, or security fabric. You will get options to manage your switches here. And there is another feature visibility. Let me show you that as well. So in firewall, in FortiGate, by default, not all features are enabled. Only certain features are enabled and most of them are disabled. So as per your requirement, if you want certain features to be enabled, you can always turn on the feature, and then you will be getting the options in the GUI accordingly. Only if I enable multicast policy, I'll be able to configure a multicast policy from the CLI, and the firewall will be capable of performing multicast. If the feature is disabled, firewall is not capable of doing that function. For example, email filter currently is disabled, so this firewall, even if I won't get the option to configure email filters. So let's head back to interfaces. So in the lab topology, I have 4 NICs connected. So port 1, 2, 3, and 4. So that is what we see here. So I have 4 ports and only one of the port 1 is configured. This is something which I configured from the GUI, sorry, from the CLI. Now let's head to configure our port 2. So before directly jumping into the configuration, I wanted to discuss certain options here. So let's check those. So there are there are multiple ways to assign IP address. So one is manual, where you can assign the IP address, and then is the DHCP mode. So if you configure the IP, if you configure the interface in DHCP mode, this interface port 2 is going to act as a DHCP client, not server. So you have to configure an upstream DHCP server for the firewall to get the IP address. Then we have the triple PoE. So similarly, this firewall is acting as a triple PoE client, not a server. So you should have a server configured to assign IP address. So IPAM we can ignore, one-arm sniffer we can ignore. We are not using this now. Now, there are two things I wanted to differentiate here. One is alias and another is the role. Alias is nothing but similar to description, which you can later refer when you configure security policies. But our main focus, I should ask you to focus on these roles. So what are these roles? So, and please don't confuse these roles with the zone names which you see on other firewalls. For example, in Palo Alto, you will see security zones. Please don't confuse these names with the security zones. These are two different concepts. So by default, you have these 4 roles available: LAN, WAN, DMC, and undefined. So why do we have these roles, predefined roles, and why do we need to define these roles? So there is a well-known issue or common mispractice which we have seen, uh, which is enabling DHCP server on your WAN interface. So if you enable DHCP on your WAN interface, or let's say you are connecting, you're doing some hands-on from your desk in your office, and you have access to your own firewall. Let's say you have a firewall in your desk, and if you connect it to your local LAN, and if you configure the firewall as a DHCP server, and all the PCs in the network will get affected, because your firewall will start behaving as a DHCP server and start assigning IPs, gateways, DNS, and DHCP. So this will, and also it can inject default route. So this will create a lot of havoc in the network. So we should never enable a DHCP server non-client in our WAN. So when I say DHCP non-client, you should not enable your WAN interface as a DHCP server and not a client. Your WAN interface can act as a DHCP client but not server. So we should be very careful during our initial deployments on this thing. So each of these roles have predefined, let's say, predefined functionalities. So settings that you can apply, and some of them are hidden based on the roles which you choose. For example, let's consider our LAN. So if I say LAN, if I am using the role as LAN, I'm going to use this interface port 2 to connect to my local segments, or the local network of endpoints. Most of my endpoints will get connected here. Now in this, I will kind of get all, but the most important thing is, if I enable the role as LAN, I will have this device detection and security mode capability. And one more thing, so if certain functions are hidden, let's say if I choose WAN, I don't have the security option here. So, but instead I have traffic shaping. So I have this this particular option as hidden. This particular device detection option is hidden if I choose WAN. That doesn't mean you cannot configure this. Those options will still be available for you in CLI. If you do show full, you will still be able to configure all these options. But the reason is, since most of us configure the firewall from GUI, we don't want to misconfigure certain things. That is why these roles are predefined and certain options are limited for us in GUI. So if the role is chosen as LAN, then the device detection, you will get the option to do device detection and also do security mode. If you do security mode, you can do captive portal authentication, which is similar in a way. Like if the user is trying to access internet, and let's say he wants to access YouTube, you can configure the firewall to throw an authentication page. So the user will get a pop-up, and only if the user authenticates, if the user is allowed, then the user, and if the authentication is successful, the user will be able to access YouTube. You can have certain controls by using this captive portal. We will discuss all these authentication methods in the later course, but I just want to show this option. Now, another option which we get with a LAN role is the address object. So whatever IP address you create here, a corresponding address object will be created based on this. So you can use this address object to later refer it in policy or SD-WAN or routing, wherever we want. But I'm just letting you know this option exists. So you don't have to manually create address object. If you don't want to use this, you can always disable this. Now, if I choose WAN as my role, then by default, you won't be able to configure this interface as DHCP server. Let me show you the difference once again. If you choose LAN, you can configure this as DHCP server. You will get the option DHCP server, and you can configure this interface as DHCP server. But if you choose the role as WAN, you won't get the DHCP server option. The reason being, we don't want you to misconfigure this firewall as a DHCP server on the WAN segment, on the WAN's facing side. Similarly, your ability to create address object is disabled, device detection is disabled. You don't want to perform device detection on the WAN. Security mode is disabled, and one arm sniffer is disabled. If you see, earlier we used to get an option one arm sniffer, that is disabled here. Now, if we choose DMC, let's see. So in DMC, again, we have the DHCP server disabled, and the security mode is not available. You don't have the captive portal authentication page option available because in most of the scenarios, you will be deploying your server forms in DMC, and in servers, there won't be anyone sitting manually to do authentication every time. So maybe your server have to reach to internet to fetch an update or download some packages. So for that reason, captive portal is disabled on this, but still you have the option to do MAC based policy. You can create policies based on MAC addresses if you need. It's not advisable, but if we need some control, we can do that. And lastly, there is an undefined role which gives you all access. So everything is available in undefined. So for this lab purposes, we will use undefined, and then so that we will get all the options from GUI. But in real-time scenarios, please choose the network roles accordingly. Now let's say undefined. Now let's assign an IP address to this interface. So what interface we have in our lab? So LAN segment is designed to is 20.110/24. So let's say 20.1.1.1/24. So this is the IP address which I am configuring on the LAN interface, that is port 2. Let's say this is LAN or remote LAN. Now, since I chose the role as undefined, all my access or services are disabled. So for the time being, let's enable HTTPS, or let's only enable ping. We don't want HTTPS. Let's enable ping on this, or let's go with HTTPS also. Now, LLDP, so it's a capability I will cover at the end of the session. Now let's configure this as DHCP server. Now, if you see the address range, we didn't do it manually. So the firewall automatically picked an IP address range, and this range is based on whatever IP address we configure for the interface. So you cannot configure your interface in one range, and you cannot have your interface in one segment and your DHCP server in another segment. You can have this option, but only after careful consideration, where you have another gateway available in the network. So let's say I can make it as 30, and I can still make it work only if I assign a specific default gateway, and I will route all the traffic through to that gateway. So this interface will only act as a DHCP server. But again, it depends on the network design. But commonly, the best practice is used to have the DHCP server and the interface in the same address segment. So I don't want to change anything here. So we are not let's inject the default, the DNS also. So let's say DNS server is 8.8.8.8. Default gateway same as interface IP. So this 20.1.1 will be passed on as a default gateway by this DHCP server. This time we don't want to change. No security mode now. Let's apply this change. So now this port 2 is acting as a DHCP server, and it's capable of assigning IP from this range. Now, okay, so the methods to access the firewall, we have the console access, then we have the GUI access, and then we have the putty or Teratam. You can use any SSH tool to connect to the firewall. But other than that, from the GUI, we have this option which we refer to as CLI console or Java console. Okay, connection limited. Since I have this, I'm not able to access it out there. Okay, let's access it from this is remote firewall. Okay, so let's check if the firewall has assigned an IP address. Okay. So admin test at the rate of 123. So execute DHCP list. So no IP is assigned yet. Let's check. So I have connected to this PC route. So let's check this interface. So the interface mode is set to DHCP. All good here. So let's apply and now the network got connected. And we got the IP address 20112. Default route or the gateway is 2111 and the DNS is 8.8. Now we got this IP address assigned by the firewall. Now if I check the DHCP lease list, you will see the firewall assigning the IP address. Let's make it big. Okay, so we have assigned this IP address 20111, the MAC address of the machine, and the host name Linux Mint, and server ID. This refers to the DHCP and the expiry details. So now we see the firewall has given us an IP address. Let's try to ping the firewall. Ping 20.1.1.1. So I'm able to reach the firewall. Let's now, if you remember, I have enabled the access HTTPS on this port 2. So now let's go back to this remote PC and let's try to access the firewall GUI from remote PC. So password is root. So HTTPS 20.1.1.1. So I'll be able to access the firewall since I have enabled the service on the interface. Admin test at the rate of 123. Let. So what we have done is we have configured the firewall port 2 as a DHCP server so that the client, that is the remote PC, got an IP address from this range. And if you see, like there is one client assigned. And from that machine, now we are able to ping this firewall and we are able to access the GUI of this firewall. And this is all happening from the remote PC. This is what I wanted to show with this. So now I believe this part that is interface configuration is a bit clear for us. There are various other options like creating tunnels, VLANs, LACP, those things which we will discuss later. But now this is the very basic part, how to get access and how to connect or assign an interface. Okay, the time is really running fast. Now, creating VLANs or interface pairs can be done from this option, create new and interface. We have an option to create various types of interface. where we can select VLAN or loopback interface and then assign the roles accordingly. I'm not going to discuss this VLAN now because of the time constraint. Let's skip this topic and we will come back to this later part. Now, once the interface configuration is done, that is the IP address assignment and connecting a client. And the next important thing is a route. If let's say, let's access the firewall CLI and get router info routing table detail. So currently there are only two routes. And if you see, both of them are connected routes. There is no static default route or there is no default route. So we don't have an option to reach internet. Now, if I do execute ping 8.8, this firewall cannot reach internet because it don't have any route to reach internet. So let's configure a route. Now, before configuring this route, as per our topology, we should have these interfaces assigned IP address in this range, 4600 and 3500. So let's quickly configure the IP address on those ports as well, then so that we can configure route and point them in the direction. Allow me a couple of minutes. 43 show. So mode is set to static, so I'm not bothered about DHCP. Set IP 35.0.0. Let's say 3.252 typo. When we say next, it will come out, but the configuration is not applied yet. So only if you type end, this is how the tree structure will look like. If I enter next, it will come out of the config, but it is not applied or written. Only if I type end, the config will be applied. So let's switch to interface port 4, set IP 46.0.3, typo. Next. Now, if I do show, I have the configuration done, but it's not written. If you can see here, port 3 and port 4, but it's not applied. Only if I hit end, the actual config will be applied to the firewall. Now, if I do diag IP address list, I see port 3 and 4 configured. Okay, now let's come back to the routing configuration. So now, as I said, there is no routes available for us. So let's head back to static routes and let's create a static route in this firewall. So creating a route from the firewall interface is very straightforward. So first we have to define the network range. Since this is going to be a default route, we can say 00/0. And if we know the gateway, if there are multiple gateways available on the upstream, then we should specify the gateway IP address. If there is only one gateway, if there is no gateway, then it's not mandatory. We can leave it as 00. Based on the ARP resolution, the gateway address IP will be taken. But we should specify the interface. So let's bind this particular default route on the port 3. So port 3 is defined with IP address 35003, and I'm pointing the default route on port 3. So the default AD value for your static route is 10. So that is what we have here. If we want to change this, we can change this. Let's make it 15, no harm in it. And if you click on advanced option, you see the priority as 1. So this is a tiebreaker used by the Fortigate. So the priority, the least priority will be preferred. So if you have multiple routes with the same AD, same prefix length, same values, then you can use the priority as a try-breaker. So let's apply this config. Now we have a default route available. So you can see we have a default route available configured with AD15 and the priority set to 1. Now if I ping 8.8, let's see if it works. No, it won't work because now in the lab topology, the perimeter firewall is turned off. So let me turn on the perimeter firewall. Once this is ready, we should be able to access the internet. I see so many questions in the chat, but I will come back to those questions after some time. So let's see if the firewall is ready. So username is admin, password is test@123. So let me show this side by side. So on the right side, we have the remote firewall, and the left, we have the perimeter firewall. Now, if you see here, get system status. The license status of your remote firewall is still in warning, but the license status of your perimeter is valid because perimeter firewall was able to access the internet and it was able to validate the license. But on the remote firewall, the internet access was not provided yet, so it's not able to access the internet. Now let's check. So the reason why the remote firewall is not able to access the internet is because the port 5 and 6 on the perimeter firewall is not configured yet. So let me quickly configure that. So this is with .3. So let's do .2 here. So let's configure port 5. And to switch between these ports, I'm using tab in my keyboard. So let's configure port 5. Show. So it's not in DHCP mode, so I can directly configure IP. Set IP. Port 5 is for 35 segment. So 35.0.0.2. Next, and edit port 6. Set IP 46.0.0.2. Let's check the routing also. So there is no default route. So let's configure a default route. Oh, what about port 3? Sorry, port 2. Okay, so in port 2 for this perimeter firewall, it should be connected to the DHCP server in our network. So let's configure port 2 in DHCP. So there's an upstream router in our physical lab, which is acting as a DHCP server. So it's set to static mode. That is why it's not receiving the IP address now. So let's configure the mode as DHCP here and end. So now port 2 should receive an IP address from the DHCP server. Let's wait. Okay, there we go. So port 2 now got an IP address from our DHCP server. So this DHCP server, now in this scenario, port 2 is acting as a DHCP client and not server. Earlier, in the case of remote firewall, we configured port 2 as a DHCP server, but in the case of perimeter firewall, port 2 is acting as a DHCP client. So it received the server. Now let's check the routing table. So there is a default route, and this default route is being injected by the DHCP server. This is not something which we configured. We got this from DHCP server. We didn't configure it manually. We are receiving it from DHCP server. Now this perimeter firewall should have access to internet. So let's check. So perimeter firewall is able to access the internet. Now let's check the remote firewall. Okay. So remote firewall is still not able to access, and the license is still warning. Now, when we say it's not able to access, there is something which I wanted to show you. So each interface will get an index assigned, index ID. So for port 1, it's index 3, for port 2, it's index 4, and index 5, 6. Every interface has its own index ID. Now, if I do an execute ping 8.8, my traffic will leave out of port 1 because port 1 has the least index, that is index 3. If you compare these index numbers, index 3 is the least one. So my traffic will leave out of port 1. If from the remote firewall perspective, if my traffic leaves out of port 1, it will go to switch, and from switch it can go to perimeter firewall port 1, or it can go to the Linux server. And either of this way, I cannot access internet if the traffic traverses through the port 1. So I want the traffic to leave out of port 3 or port 4. During Fortigate, now this is an important thing in Fortigate troubleshooting. When you do a ping, it's always important to source the traffic. Now, if you compare the same thing on this firewall, port 2 had the index ID 4. So this is the least value, not the port 1. You see the difference? That is the reason why from this firewall, from perimeter firewall, I am directly able to access the internet when I run the command execute ping 8.8. Because the port 2 has the least index, value, it was able to access the internet using this interface. On the other hand, in our remote firewall, the index 3 is assigned to port number 1, and through this way we cannot access internet. So what we can do is we can run the command. Let me bring it here. Execute ping option. You will get various options, and one of them is to select the interface. So you can select the interface, and you can specify port 3. So now you have let me show the setting. Interface option, so view settings. So you will see that now my traffic will be sourced from interface port 3. Now if I do ping, I should be able to reach 8.8. Okay, I found the issue. So there is a policy missing in this perimeter firewall. So let's quickly configure the policy also. Allow me 1 minute. I had this configuration in place, but when I wiped the lab, we lost all the configuration. System, allow me 2 minutes. One 192.168 1 dot, let's say 2.0 end. Let me access the GUI of this perimeter firewall, and let me quickly configure a policy. This is 1.3. Okay. 68.1.2. Guys, please don't mind me skipping or explaining what I'm doing. We are running short of time, so in the later stage, we will have a detailed study on all these features. So I'm looking for multiple interface policy, so this will make my life easier. I don't have to configure policies for specific interface. So create new test. So since I enabled that option multiple interface, now I can create this any policy. By default, we won't get that option. So we are using in this lab, we are using the perimeter as kind of as a router. So, but in later part, we will use other options as well. So let's see. Now the policy is in place, route is in place. Now, if I check from the remote firewall, I should be able to access internet. It should be allowed by the perimeter firewall by now. So packet loss. What am I missing? Route pointing in port 3. 30.3 and 30.2. So we have this inbuilt sniffer option available in Fortigate firewall, so I can check if what the traffic is, how the traffic is handled. So we are receiving this traffic on port 5 of this firewall. Okay, let me check the topology. Okay, from port on remote firewall, traffic will leave port 3 and ingress on port 5. Okay, and what it says, we are only receiving the ARP. So remote firewall is not able to resolve the ARP for 8.8. That is the reason why we are not able to communicate. Okay, let me check the perimeter. So policy has not taken hit because ARP is having issue. Let me quickly do a test. Let's see if this we can able to reach the port 5. Let's say ping. Let's enable the service on perimeter and let's check. Ping option source. Oh, okay. Let's set the so now if you check this view setting, we have this interface set, but we haven't set the source IP address for the ping. So source address is still set to auto. So let's set the source IP address. Ping option source 30 dot, what was the IP? 003, 35. Did I use 35 here? Okay. Now execute ping 8.8. So still ARP issue. 35.00.2. Okay, I'm having issues with my gateway. So let's say 35.0.0.3. Let's sniff for all the traffic coming from this IP. So if you see from remote firewall, we are sending the echo request that is being received by the perimeter, but it is having ARP issues. So for that reason, it's not able to communicate. I need to check what's wrong at the backend. It should work without making any further changes. So we are receiving the ARP request, but there's no response. I send the request, but there is no response. Okay, the time is running out, so I need to troubleshoot this on the back end on the VM level. So something is wrong and ARP is not working, but ideally they should work. Let's not waste further time in this. We have 10 more minutes left. I will use this time to answer your questions, but I also had other topics like admin profiles, VDOMs, trusted source. So all these things are prepared for today's session, but because of time constraint, we are not going to cover those topics. We will see if we can squeeze this in some other time. Maybe we will extend 1 or 2 days more, and then we will cover this. Now let's come back to the Q&A session. God, there are 70 chats I have. So let me check those chats. So guys, I'm going to get the questions from the chat and I will use the time to answer those. There's a question from Rishabh, how to get the passcode for the lab environment. So you will get, so the default passcode. So let me log out. So this passcode you will get from the NG app. So once you have the app, sign in and you will get the passcode for the lab from there. Friendly, can the course is friendly to learn for beginners? Ramu, I believe I answered the question already. So can we have the recording available for future reference? I have recorded this session, so we will share this with you. So there's a message from Kunal. I have deployed one Fortigate VM on my desktop, free license purchased in Fortigate. All the requirement VM, but the license cable, but it is showing proxy error. Kunal, the proxy error is happening because of your local machine's firewall. So you can turn it off and you'll be able to access. So firewall, it will communicate to the FortiGuard servers in the backend. So please allow that connection and you'll be able to access. So there's another question from Gunal, how to create an IPsec site-to-site tunnel in FortiGate firewall. Kindly share the config file. It will help to build IPsec in my firewall. So Kunal, IPsec we have planned for another day. So if time permits, we will cover it in the bootcamp. If not, we will cover it in the full course. So, and the question from Shiva, explain the packet flow whenever is possible. Shiva, I will plan it for one day in our bootcamp session. I will explain the packet flow, how to debug the packets in FortiGate firewall, and how to troubleshoot any issues there. So, another question from user 018215, difference between stateful and stateless. So in stateful firewall will maintain a session table. So it doesn't have, you don't have to create two policies in each direction to allow a connection. You can create policy from the initiator direction and that will allow the connection on the reply direction. But in stateless, there is no session table maintained. So you have to create two policies for each flow. That's the basic difference. Oh, so thank you, Abhishek. You have answered the question on chat. It's very helpful. Another question from Rushabh. Can you share any one of explain a Fortigate model for distributed enterprise firewall? So distributed enterprise firewall, let me bring that up. One moment. Let me bring that layer for reference as well. So distributed firewalls are usually deployed at the remote office level. So we can have like uh, 30E E series is going away because they are going to reach the end of support in upcoming years. So you can go for like 60F, 80F, or even G series models. So what is the difference between G and F series model? Question from Davala. So the model difference is basically in terms of the hardware. So F series has NP6 and or NP6 Lite, I believe, and a G series will have maybe NP7 or some other hardware change. So in terms of FortiOS capabilities, they will be the same, but the performance will change. Maybe the CPU architecture will change, CPU models will change, or the chipsets, the NP chips might change. So Krishna Kumar was not able to access the bootcamp session. Can you provide me lab access? Krishna Kumar, this you will be able to get the access and support via the application. So Kunal has a question. Which version of the firewall will support quantum cryptography? I really doubt that firewalls nowadays support quantum cryptography. Kunal, are you asking this question in terms of decrypting the traffic with quantum cryptography or supporting the encrypting the traffic? Please give a clarity on that. So Abdul, can you please explain DC firewall again? So basically, Abdul, DC firewalls are firewalls capable of having high processing power. So we want those firewalls to handle traffic in terms of TB, and we don't want to use those firewalls for decrypting the traffic because traffic decryption is either performed on segmentation level or the perimeter level. So we normally don't deploy DC firewalls to decrypt the traffic. This is just to have remove some load of the firewall. That's the obvious reason. So, uh, Mareshwaran, what do you mean by perimeter? Okay, Abhishek has answered that question. Thank you, Abhishek. So Shankar has a question. Do we really need internal segmentation firewalls? Aren't access routers deployed in remote offices capable of ACL? Shankar, internal segmentation firewall is not only about the segmentation. It's about the control. So let's say you have two segments. One is HR and another is developers. So you want your HRs to access LinkedIn, but you don't want your developers to access LinkedIn from your enterprise network. So these level of controls cannot be done using standard ACLs or extended ACLs. For that purpose, for that layer 7 inspection, you need firewalls. Nadeem, could you write the name of the deployment type as well with the topology? Uh, Nadeem, it's really not about the topology. It's about the functionality where you're using. It has nothing to do with the topology. So Pavan has an issue about the lab hours. So Pavan, the lab hours is based on the number of CPUs which we are using. So if we use 4 CPUs in the topology, let me go back. If I use 4 CPUs or 2 CPUs in this device, each minute will be counted as 2 minutes. For example, on the remote firewall, I'm using 2 CPU. So if you run the firewall for 1 minute, it will be counted as 2 minutes with in terms of consumption. So please keep that in mind. So Nazim, you're not able to receive OTP as you're using UAE number. Uh, please message on the group and sorry, please messages on WhatsApp. It will help you get the OTP and have the app set up. So Mariappan, you are unable to open the CLI or HTTPS. Let me quickly show that as well. So when uh, when you log in, you have two options, whether you use browser console or you use native console. So use the native console so that all the tools will be installed. And then if you click on the devices, you'll be able to open the console and HTTPS accordingly, depending on the mission. So Nadeem, no password is working. It will work only on the first time. Once we import the configuration to set up the license and everything, the password will change to test at the rate of 123. So what option do we get for DMC? So in DMC, usually you won't get the option for let me log in and show. This question is from Rushabh Shah. Admin test at the rate of 123. So this is the remote firewall which we have accessed now. So let's see. So port 5. So if okay, let me choose another interface. Port 4. So if I choose the option as DMC, basically I won't be able to configure it as DHCP server, and also the captive portal, that is security feature, will be disabled. So there is no captive portal functionality for DMC. So EC2 has a question, what is AD? AD is administrative distance. It's a tiebreaker used for route selection. Uh, Money has a question. Can you explain VDOM? Money, I had this uh, session prepared for VDOM, but because of time constraint, we were not able to complete it. So there's a user Xiaomi who has a question. Is port have capability like 10 gig or 1 gig? So so the port speeds, the capability for these ports varies with respect to model. So if I use a entry level models, they'll be capable of 1 gig. Maybe a couple of ports will be capable of 10 gig. Let me show this. One moment. So let's say Fortigate 2601F. So this is a model which is higher end, which we will say as higher end model. So if you see, you will get different classes of ports here. So you will get RJ45, you will get SFP, QSFP ports. Now these QSFP ports, that is port 33 to 36, they will be like 40 gig ports, and maybe SFP or like 10 gig, then RJ45 or 10 gig. And you will also, there are also models which provides 100 gig ports. So it depends. It's the port capability really depends on the model which we are using. Akshay, you asked me to explain VDOM, which we will do it later. So Jabakumar has a question. Could you please explain physical and virtual firewalls, its pros and cons? But can we use virtual firewall in all layers? So, Jabakumar, it depends on the deployment. If you traditionally in enterprise networks, customers use physical firewalls on their on-site deployments. But if they have any servers in cloud, they will use virtual. But optionally, let's say you have all your servers running virtually in your local DC. Let's say you have an ESXi server and all your application servers, DB servers are running in that ESXi. You can deploy a Fortigate VM in that ESXi and you can make it do all the security processing. So that is also possible. So Prasanna, I got your suggestion that I should check the chat and answer it time to time. I will keep this in mind. From tomorrow, I will try to answer these questions on time to time basis. So, Rishabh has a question. In Fortinet firewalls, we usually see separate physical DMZ port. Is there any special use cases of this port which is different than others? So, Rishabh, you will see these port marking as DMZ only in entry-level models. So, if a port is marked as a DMZ on the interface front panel, then the role for that interface will also be selected as DMZ. So if you want to use it for other roles, you can always change the configuration from the GUI or CLI. But there is no specific use cases defined. But for entry-level models, it's typical that they have only 4 ports. One will be for management, one for WAN, one for LAN, and one for DMZ. So that is why you see those markings in it. Okay, that's all for the day. I hope I have answered all the questions. So, once again, I want to thank you all for taking this time on a Saturday morning to attend this session. I really appreciate this, and I'm looking forward for all of you to connect for another session tomorrow. So, there are certain topics which I'm not able to complete because of time constraint. We will try to extend a session for maybe for 7 or 8 days, this bootcamp, and then we will complete it there. Or we will cover all these topics in a detailed way, in a slow manner, in our full course session. Yeah. And once again, thank you all for a day and have a good day.